Hi, different type question for Bernoulli differential equation, and let's solve together. If you realize in this question the coefficient of derivative does not equal to 1, but what we know about linear and Bernoulli type differential equation, the coefficient of derivative must be 1. First of all, to mention about Bernoulli differential equation, first things we have to make the coefficient of derivative 1. So to make it 1, we have to remove term of x. That's why let us divide by x square, whole equation by x square to make it 1. So x square y prime over x square, 2x square y over x square, and there is 5x cubed over y divided by x square. So x square removed, this is y prime. Here 2y, and here 5x cubed over x square, 5x over y. But the term that we have on the right side about term of y, the term of y must be in numerator, y to the power of n. So this is in denominator. Let us send these things to numerator to mention about Bernoulli because it's power n. But what's n here? The term of y, we know that on numerator. That's why let's send this to numerator. 5x times y to the power of minus 1. That's why n equal minus 1. If you start here and say, sir, n equal 1, it means you made a mistake and you cannot obtain linear equation after substitution. So n equal minus 1. What is the first aim for us? Our aim is to make this differential equation linear differential equation. But what we know in linear differential equation, there is no term of y on the right side, so we have to remove this part from right side. How we remove? Let's divide by this term. Divide by this term. The first divide by this term means y to the power of minus 1. Let's divide y prime over y to the power of minus 1, 2y over y to the power of minus 1, 5x over y to the power of minus 1. So here, if we send y to the power of minus 1 to numerator, this is y times y prime. If we send, this will be y to the power of 1 times y, here plus 2y square, and here and 5x. If you want, if you can see directly n equal minus 1, not necessary to put these things to numerator. You can say here directly n equal minus 1, and instead of dividing, again dividing by y to the power of minus 1, in this step you can say let's multiply by y to remove term of y on the right side. You can multiply by y and you can obtain the same things, but directly you must see that n equal minus 1 first of all. So here what we know, after substitution, this part must give us z, and this part must give us z prime. So what is substitution? Substitution was z equal y to the power of 1 minus m. So z equal y to the power of, what is m? n is minus 1. 1 minus minus 1 will be plus 1. 1 plus 1 equal 2. Z equal y square, exactly it gives us z. So we made everything correct until here. So let's take derivative. Z will be z prime. Derivative of this part 2y, and don't forget to put y prime because you are taking derivative. And what we know, this part gives us z prime, that is derivative, but this is y prime. Y prime, there exists 2, but here there is no 2. But we have to obtain these things to write z prime. What's the missing part? 2. So that's why we have to multiply our equation by 2. Our equation by 2, because our aim is to obtain this derivative z prime. Let's multiply 2y prime, 4y square, 10x. So look, this part exactly z prime. This part y square exactly z. That's why we made everything correct until here. So equal z prime 4z 10x. You see y prime, y, there is no y on the right side. Instead of y we have z, z prime z, and there is no z on the right side. That's why this is linear differential equation. So what is px? Px coefficient of z, and qx the function that we have on the right side. What's integration factor? Exponential px dx, exponential for dx, because px is 4, exponential for x. So, and let's obtain last result. What's the solution for us? Z equal, normally it was y, but instead of y we have z. Z equal 1 over mu integral mu times q dx plus c. Let's continue. What is z? Z equal y squared 1 over exponential for x integral mu times q, or q times mu. Q equal 10x and mu equal exponential for x dx plus c. What's this integral? Exponential for x plus times 10x. You can use integration by parts, or there is a simple techniques if we have polynomials times trigonometric function or polynomials times exponential function. For the polynomial part and exponential part. For the polynomial part, take derivative of 10x 10, derivative of 10 0. For the exponential part, take integral of exponential for x over 4, and again integral exponential for x over 4 times 4 will be 16. And if we want to find result, we have to make cross product and the sign plus minus plus. So here there is y squared. Send exponential for x to numerator, exponential minus 4x, and the integral will comes cross product 10x times exponential for x over 4. Here 10 times this part there is minus 10 times exponential for x over 16. It's finished, and there is plus c. Let's continue. Y square here, exponential minus 4x times exponential for x removed, 10x over 4. 10x over 4 will be 5x over 2. And here exponential for x, exponential minus 4x removed, minus 10 over 16, minus 5 over 8. And if you multiply, c times exponential minus 4x. If you want to write instead of y squared just y, take square root, it will be y equals square root of right side, and this is our last result. The important things here is, if the term of y in denominator, you have to send to numerator to check real power for us to find m. This is the important things for us.